I bet you didn't know the incredible story behind the space shuttle. Imagine a vehicle. It could launch like a rocket, it could orbit Earth like a spaceship, and it could return to land like a plane. This was the dream of the space shuttle. The idea for a reusable spacecraft emerged in the 1960s. It was a bold vision for the future of space travel. Before the shuttle, rockets were used only once. Each launch was very expensive. Scientists and engineers wanted a more cost-effective solution. They imagined a spacecraft that could fly multiple missions. The space shuttle was designed to be that solution. It was developed by NASA in the 1970s. The shuttle was a complex and sophisticated machine. It pushed the boundaries of engineering and technology. The first space shuttle, Enterprise, was unveiled in 1976. It never flew in space but was used for important testing. Enterprise helped pave the way for the operational space shuttles that would follow. The space shuttle was the world's first reusable spacecraft. This was a major breakthrough in space technology. Reusability meant lower costs for space missions. It also meant more frequent flights. Imagine a plane that could only fly once. That's how rockets used to be. The space shuttle changed everything. It could launch into space, deliver payloads, and return to Earth for reuse. This reusability was central to the shuttle's purpose. It allowed for more ambitious and frequent missions. Scientists could now conduct long-term research in space. They could deploy and repair satellites more easily. The shuttle was designed to transport astronauts and cargo to low Earth orbit. It played a critical role in building the International Space Station. The ISS is a large spacecraft that orbits Earth. It serves as a laboratory for scientific research. The space shuttle flew over 130 missions into space. Each mission had unique objectives and contributed to our understanding of space. The shuttles carried astronauts, satellites, and even parts for the International Space Station. One of the primary missions of the space shuttle was scientific research. Astronauts conducted experiments in microgravity. They studied biology, physics, and astronomy. The shuttle also deployed telescopes and other scientific instruments. The shuttle program played a crucial role in the assembly of the International Space Station. Over several missions, shuttles delivered components, supplies, and crew members to the station. The ISS is a testament to international collaboration in space exploration. The space shuttle also performed maintenance and repair missions for satellites already in orbit. Astronauts would capture satellites with the shuttle's robotic arm. They would then repair them or return them to Earth for refurbishment. The space shuttle was a complex machine made up of over 2.5 million parts. Understanding its key components helps us appreciate the engineering marvel that it was. The shuttle consisted of three main parts: the orbiter, the solid rocket boosters, and the external tank. The orbiter resembled an airplane and housed the crew and payload. It was the part of the shuttle that returned to Earth and landed like a glider. The orbiter contained the crew compartment, the payload bay, and the three main engines. The solid rocket boosters provided the initial thrust for liftoff. These were the two large white rockets attached to the sides of the external tank. They burned solid fuel and were jettisoned after about 2 minutes into the flight. The external tank was the largest part of the space shuttle. It contained the liquid hydrogen and liquid oxygen fuel for the orbiter's main engines. The external tank was jettisoned after the main engines shut down, and it disintegrated upon re-entry into the Earth's atmosphere. Section 5. Powering the Dream, the Solid Rocket Boosters. The Space Shuttle's solid rocket boosters, or SRBs, were an awe-inspiring sight. They were the two massive white rockets strapped to the sides of the external tank. These powerful boosters provided the initial thrust needed to lift the shuttle off the launch pad. Each SRB was 149 feet tall and 12 feet in diameter. They were filled with a solid propellant mixture, primarily composed of aluminum powder as fuel and ammonium perchlorate as an oxidizer. This mixture, when ignited, produced an enormous amount of thrust. The SRBs burned for approximately 2 minutes after liftoff. During this time, they provided about 80% of the thrust needed to propel the shuttle skyward. Once their fuel was exhausted, they detached from the external tank and parachuted back to Earth. The SRBs were recovered from the ocean and could be reused after refurbishment. This reusability contributed to the cost-effectiveness of the Space Shuttle program. The SRBs were a testament to the power of solid rocket technology. Section 6. A tank of immense proportions, the external tank. The Space Shuttle's external tank was hard to miss. It was the largest single component of the shuttle, towering over the orbiter and SRBs on the launch pad. This massive orange tank was essential for providing fuel to the orbiter's three main engines during launch and ascent. The external tank was 154 feet tall and 27.6 feet in diameter. It was the only part of the space shuttle that was not reusable. After its fuel was depleted, it separated from the orbiter and broke apart upon re-entry into the Earth's atmosphere. The tank was divided into two sections, a larger tank for liquid hydrogen and a smaller tank for liquid oxygen. These two liquids, when mixed and ignited in the orbiter's main engines, produced an extremely powerful combustion reaction. The external tank was a marvel of engineering. It had to be incredibly lightweight, yet strong enough to withstand the stresses of launch and ascent. It played a vital role in delivering the shuttle and its crew to space. Columbia and Atlantis, Legends of the Space Shuttle Program. Columbia and Atlantis hold a special place in history. They flew numerous missions, advancing space exploration. Columbia was the first space shuttle to fly into orbit. Its maiden voyage in 1981 began the operational program. Columbia tragically disintegrated during re-entry in 2003. Atlantis flew 33 missions. It deployed satellites and serviced the Hubble Space Telescope. Atlantis's final mission in 2011 marked the program's end. These shuttles represent human ingenuity and exploration. The Space Shuttle program was a hotbed of technological innovation. It pushed the boundaries of engineering, materials science, and computer technology. Many of the advancements made during the program have found applications in various fields, benefiting society as a whole. One of the most significant technological achievements of the shuttle program was the development of the first reusable spacecraft. This breakthrough paved the way for more cost-effective and sustainable space transportation systems. The shuttle program also led to advancements in thermal protection systems. The orbiter's heat shield, designed to withstand the extreme temperatures of re-entry, spurred the development of new materials and insulation techniques used in various industries. Furthermore, the shuttle program advanced computer technology. The shuttle's onboard computers were at the forefront of computing power in their time. They required innovative software and hardware solutions that have since found applications in aviation, medicine, and other fields. The Space Shuttle program, though now concluded, left an enduring legacy that continues to inspire and shape our future in space. The program demonstrated the power of human ingenuity and international collaboration in achieving ambitious goals. The shuttle program expanded our understanding of space. It allowed us to conduct scientific research in microgravity, deploy telescopes, and study our planet from a unique vantage point. The data collected during shuttle missions continues to fuel scientific discoveries today. The program also played a pivotal role in international collaboration. The International Space Station, a testament to global partnership in space exploration, would not have been possible without the Space Shuttle. This collaboration continues to foster cooperation and shared goals in space research. The Space Shuttle program, though officially retired, continues to inspire new generations of scientists, engineers, and astronauts. The lessons learned and technologies developed during its 3 decades of operation continue to inform and influence the future of space exploration. The Space Shuttle program had a profound impact on education, particularly in the fields of science, technology, engineering, and mathematics, STEM. The program's achievements ignited the imaginations of countless young minds, inspiring them to pursue careers in STEM fields. The shuttle missions, often televised globally, provided a front-row seat to the wonders of space exploration. They showcased the excitement and challenges of working in STEM fields, making these careers more accessible and appealing to young audiences. The program also led to the development of educational resources and programs for students and educators. NASA made available images, videos, and lesson plans related to the shuttle program, enriching STEM education in classrooms worldwide. The shuttle program's legacy continues to inspire STEM education today. Many museums and science centers feature exhibits dedicated to the space shuttle, allowing visitors to learn about its history and technology. The program's impact on STEM education ensures a future generation of explorers and innovators. The retirement of the Space Shuttle program marked the end of an era, but it also ushered in a new age of space exploration. With renewed focus and international collaboration, we are venturing further into the cosmos. Private companies are now playing an increasingly significant role in space exploration. These endeavors are making space more accessible and affordable. International partnerships drive ambitious missions. The ISS remains a symbol of global cooperation, with future missions to the Moon and Mars. The future of space exploration is brimming with possibilities. If you enjoyed this journey through space shuttle technology, don't forget to like, comment, and subscribe for more exciting content.